this was the one. Yeah, tell me what is the doubt, better.
So here they have given this relative density, 1.005, which we are not using anywhere
It
in the
doesn't,
question.
under lost buoyancy method, it does not make a difference. If you were to use the added weight method, it will make a difference, right, beta?
Yes, sir.
Because volume of buoyancy will be the water volume of the water displaced to support the thing. So in this, the drafts are given in this density, doesn't make a difference, right?
Yes, sir.
Okay.
Okay.
So what will happen inside the bilge compartment also, this water of RD 1.005 will only go, na bete?
Yeah.
So if you add it
That's
using
what I
added
was
weight
asking.
method, then this information becomes relevant. Otherwise, under lost buoyancy method, it is irrelevant, right?
Yeah, and if in the question they ask us to calculate it in seawater, then we have to do the
No,
changes.
no. What do you mean by calculate in seawater?
Like
They,
presently the condition is in dock
you
water. That's why we need
have you
something.
seen a question like this?
No, I'm just taking it
So
hypothesis.
when this density is immaterial, as long as the draft remains same, the answers would not change. No?
Yes, sir.
Only thing is, if the same ship goes to seawater, the draft may not be 3 meters, it may be 2.95 or something, maybe there's the rise.
Yeah.
So then he has to give you draft there. No? Yes or no?
Yes. Yes, sir.
Yeah. Okay.
Okay.
Okay, fine. Guys, any more doubts? I hope this question everybody was able to solve, or there are doubts on this.
सर
Sir, in
केबी
this
का थोड़ा
question,
समझा दीजिए सर.
yes,
Okay.
KV का.
Okay. Let me quickly take you through. It will not take much time. Only thing is, those who can have solved can keep giving me the values as I get going. So length 100 meters. If you don't follow these steps, you are not going to reach the end. That much I can tell you better. Floating on an even keel at a draft of 6 meters, has a midship compartment of 30-meter length, 20-meter breadth, has a DB of H 2 meters. You have cargo out here. This question. The permeability of the cargo is 40%. Okay. Now this thing gets bilged below the water line. It gets bilged below the water line, damaging both cargo compartment as well as the DB. So what will happen? The lost buoyancy will be, this part will be also lost, and some of this would also be lost. If you want to do this, it's okay. I have increased the spacing between the lines. That means lesser would be lost on top, or you can double shade this one and single shade above. Whichever way you feel comfortable, it's okay. That's not something binding on everybody. Okay. This becomes D minus H beta. That is, in this case, it will be 4 meters. Okay. Now this will cause the vessel to sink to a new waterline W1L1, which will take you to a new draft of D1. Now the water will rise here in this part based on permeability. Okay. And then we have the water plane in way of W1L1. In way of W1L1, the water plane will be lost with permeability, because you'll be able to see cargo when you cut the ship at W1L1. You'll be able to see this. So L will be 100 meters, breadth will be 20 meters, small l will be 30 meters, small b will be 20 meters. Does everybody agree? And there will be some loss of water plane here based on permeability. Guys, does everybody agree with the two diagrams, or anybody in the class is having a doubt about the diagram? Anybody? Speak up, please, if you have any doubt about the diagram, guys.
No, sir.
None? Are the two diagrams okay? Those who are asking about KB, are you comfortable with the diagrams, Mate?
Yes.
Okay. Then sinkage will be equal to, let's run through, buoyancy lost, full buoyancy, full volume of the DB. So that is L LBH, and 40% of up to the water line, so that will be plus LBD minus H into permeability divided by intact water plane. This numerator has come from the profile side elevation. The denominator will come from the water plane area, whole water plane LB minus LBP. And when you put these values, it will be 30 into 20 into 2 plus 30 into 20 into 4 into 0.4 permeability divided by 100 into 20 minus 30 into 20 into 0.4. And what is the sinkage? Is it coming 1.227 or any mistake in this? Guys, anybody having doubt about the sinkage, please clarify now. All good about sinkage? Guys, KB party, were you okay up to this point?
Yes, sir. Yes.
Okay. This gives you D1. So this gives you, let me write here so that it's clearly visible, 7.227 is the D1. Okay. Now we have to find the KB. Now guys, the water plane is changing in the way of dB up to 2 meters. The complete water plane is lost. If I use the previous slide, up to 2 meters, the water plane would be like this, with this thing completely lost. This is up to 2 meters. Above the 2 meter, the water plane would be like this as has been drawn here. Does everybody agree? Yes or no? AB party, do you agree that the water plane changes at 2 meters? Yes or no? This is
Yes.
up to 2
Yes.
meters.
Yes,
Full
sir.
thing is lost. About 2 meters, only partial loss. Yes or no?
Yes, sir.
So therefore, it cannot be calculated by as d1 by 2. It has to be calculated by moments. Okay. Let's calculate it by moments. So KB final. First, write down the notational form. Vertical moment of underwater volume. Talk to yourself like this. Vertical moment of the underwater volume up to W1 L1. What is the underwater volume? LBD1. Then asking yourself a question, what is its sliver? D1 by 2. From this, there are two volumes. From this, you don't have to make that much of thing on this anyway. There are two volumes which are under the water but not contributing to buoyancy. So we will knock off their moments. Vertical moment of the buoyancy lost in way of the dB will be LBH into H by 2. Everybody has understood what have I done now? I have allowed for the vertical moment of the buoyancy lost up to 2 meters. Is that clear, beta? Yes or no?
Sir,
Sir,
instructor,
everything is clear, sir.
why you remove that one, sir?
What did I remove?
No, no. Why you are going to minus this segment, sir?
How did we
Meter.
calculate KB yesterday? By moments.
Yes, sir. But this area also big, na, sir?
So I'm coming to that, no? You have missed out what I said. I said this is the vertical moment of the buoyancy lost in the way of dB. You missed out the last words.
Okay.
Now, is it clear? This is the buoyancy lost in the way of dB. Does it make sense now, bete? Yes or no?
Okay, sir.
Besides that, you have also this underwater volume, which I am bounding by a green line in the diagram, whose height is D1 minus H, which is also partially lost. What is that volume which I have bound by the green box, which is under the water but not contributing to buoyancy? Let me first write the volume. Volume is LB D1 minus H into permeability. This is the volume bound by the green box? Yes or no, guys? Yes or no? LB into D1 minus H into P is the volume bound by the green box. This is the volume which is under the water in the way of the cargo hold but not contributing to buoyancy, right, guys? Yes or no? अरे भाई जिनको जिनको केबी का डाउट था बोलो ना, या तो यस बोलो या डाउट बोलो.
Yes, sir. Yes, sir. Understood.
Then we have to find its liver. Where is the geometric center of this one? Geometric center of this one is here. What is this distance? It is d1 minus h by 2 plus h. So d1 minus h by 2 plus h. Is that clear now? That becomes the
Yes.
vertical moment of the underwater volume in the way of the cargo space, not contributing to buoyancy, divided by volume of buoyancy or volume of displacement, LBD. Now I put the values 100 into 20 into 7.227. You write like this and then pick up the calculator and in one go write the answer. Minus 30 into 20 into 2 into 1 minus 30 into 20 into D1 minus H will be 7.27, so 5.227 into permeability 0.4 into the liver. Now D1 minus H is 5.227. So you'll make half of 5.227 and add 2 to it. So that will be 5.227 divided by 2 plus 2 makes it 4.614. 4.614. Is this clear now, bete? Divided by the whole thing divided by 100 into 20 into 6. Is the expression clear before you solve it? Because when
Sir,
you solve it,
sir,
answer
lever,
would be
lever.
3.770 meter only, right? But is the expression clear?
सर लीवर का बता दीजिए सर इसका d1 minus h
बता,
by 2 plus
अभी
h.
बताया तो तुम्हें. Where is the
नहीं है
geometric
ऐसा तो मेरे
center?
को.
अरे where is the geometric center of the green box, भाई? It is marked in the diagram. No, I've just marked it in the diagram, beta. Where is the geometric center of the green box?
ग्रीन बॉक्स
And
के
what
सेंटर में सर.
and what will be its distance from the keel then? That is the liver. So tell me, how much is the distance of the geometric center up to the tank top, up to the DB top? यहाँ तक कितना distance होगा ये?
d1 minus h by 2 plus h. ठीक है सर.
And then how much more to keel? How much more to keel? Another 2 meters. Yes or no? Is this distance d1 minus h by 2? Yes or no?
हाँ सर, आगे सर आगे d1 minus h by 2.
So identify the center and see what is the distance. Guys, is the expression clear now?
Yes, sir.
Okay. As far as BM is concerned, I don't think there is any challenge because you'll be using the water plane area at W1, L1. Center of flotation. Oh, let me change the marker. Its laser is on. Okay, because these are okay. Here is the center of flotation. It happens to be the center line. So BMT will be equal to ICL, right like this. I am doing the full question, all these steps, nothing more required than this, guys. Intact water plane upon V, ICL of the whole water plane minus ICL of the lost water plane upon V. ICL of the whole water plane is LB cubed by 12. ICL of the lost water plane is LB cubed by 12 into permeability. Volume of displacement is LBD. We put the values here. Multiplied by 0.4 divided by 100 into 20 into 6. And this will give you BM of 4.889 meters. Anybody has any doubts in the BM part?
No.
And then of course KB GM will be equal to KB of 3.770 plus BM of 4.889 minus the given kg of 7.5. The answer should come as 1.159 meters. You can review this, and if you still have any doubts, please feel free to clarify.
Sorry, KB में it is D1 minus H by 2 plus 2 meters, no?
Yes, I have not done it. I have done it now.
Okay.
You on the calculator, you make half of 5.227. What is D1 minus H? 5.227, no?
हाँ, yes sir, अगर आपने कैलकुलेट उसमें एक्सप्रेशन में नहीं लिखा था सर, इसलिए पूछा था. ओके,
एक्सप्रेशन में यहाँ लिखा है ना, जहाँ पे फॉर्मूले में लिखा है, यहाँ तो लिखा है ना. जब वैल्यू डालूंगा तो थोड़ी लिखूंगा उसको. यहाँ तो लिखा हुआ है ना, दिस वैल्यू इज दिस मच.
ओके ओके.
यस और नो? ऊपर लिखा है ना क्लियरली D1 minus H by 2 plus H, राइट बेटा?
यस ओके ओके गॉट इट.
So 5.227 को कैलकुलेटर पे मैंने I was speaking out. I divided by 2 and then I added 2. I spoke that out. And then I said
Sir,
it is
we
so
are-
much.
वी आर यूजिंग दिस केबी फॉर्मूला क्योंकि ये जो है इंटैक्ट नहीं, मतलब जो ये एरिया है वो एक सिंगल एरिया नहीं है और हाफ हम इसका कर नहीं सकते.
बेटा तूने लेट ज्वाइन किया है क्या?
नो सर, मतलब ये
So did I not pose this question whether it is D1 by 2, yes or no? Was this question put to the class?
यस सर.
So then
सर
what
मैं
happened
पूछ
that
रहा
time?
था सर, मैं अगर मैं मतलब
नहीं
हम लोग क्या
नहीं, let's let बेटा नहीं, this is not my way of teaching ना. We
Okay, okay.
stopped at that point. I asked this question, is KB going to be D1 by 2? I went to the back slide, I drew the other area also. And now you're saying why KB is not D1 by 2?
नहीं सर, वो तो समझ में
That
आ गया
means
सर.
either you're not listening or you are not in the class. It has to be one of the two
व्हाट आई एम
things.
सेइंग इज सर, मैं एग्जाम में अगर मैं D1 by 2 भी अपर मैं इस एक्सप्रेशन से कर दूं कैलकुलेट, थोड़ा टाइम वेस्ट होगा पर कर सकता हूं ना वो.
What did I say yesterday? That if you have any doubt, always use the moments.
ओके सर, अंडरस्टूड.
That was also emphasized upon yesterday. But
Yes, yes,
I don't
understood.
leave anything to doubt. यार तुम सुनते नहीं हो, बस इतनी
हाँ सर,
problem
वही
है तुम्हारी.
मतलब कि मेरे को कभी-कभी अगर डाउट हुआ तो मैं तो सीधा ये मोमेंट्स वाला यूज
बेटा
करके
जो
खत्म कर
फर्स्ट
सकता हूं.
क्वेश्चन हमने किया था in which it was D1 by 2,
D1 by 2, yes sir.
in that also I solved by moments and showed
Yes,
you
sir,
na,
yes,
that
sir,
it's
solved,
coming
yes, sir.
D1 by 2.
Yes, correct sir.
Correct? So,
Okay sir.
and in the second question I said you can save time if you are sure about it. But
Yes
whenever
sir.
you have doubt,
Use
please
this
go
formula.
back to moments. If it is
Okay sir.
D1 by 2, the calculation will give you D1 by 2, then no issues.
Okay sir, thank you.
Okay, guys. All those who had problem with this question, is it done better now?
Yes, sir.
Diagrams, steps, jitna maine likha hai, this is the minimum and this should be where you should stop it actually. Anything more than that you write, you'll mess it up for yourself, you'll waste time. Anyway, more you want to write is your choice. I can't comment on that. But anything less than this is not acceptable, beta. Okay, we continue with this, and now we come to some more things which probably were not covered yesterday. Now, in some of your MMD questions, the permeability which was given yesterday as 80% or 40% or whatever, that is not given directly as permeability. What are you actually given then is, you are given the RD of the cargo and you are given the stowage factor of the cargo. And they do not provide you permeability. So rest of the working does not get impacted. What gets added to it at the beginning of the question is calculation of permeability. Okay, guys. So if the question comes like that, please do calculate permeability and you should know how to calculate permeability. Okay. Now, what is the density? Density of the cargo. Density of the cargo is basically, if I say the density of the cargo is, let us say, let's say 0.9 tons per cubic meter. What does it mean? That the cargo, 1 cubic meter of cargo occupies 1 cubic meter of cargo weighs 0.9 tons. Yes or no? 1 cubic meter cargo weighs 0.9 tons. That's the meaning of this expression, guys. Yes or no?
Yes, sir.
Correct?
Yes.
If the density is 0.9 tons per cubic meter, it means 1 cubic meter of cargo weighs, you don't have to write 0.9 tons. Now, this will depend on the nature of the cargo. If you have iron ore and you take 1 cubic meter, it will weigh more. If you take cotton, you take 1 cubic meter volume, it will weigh less. And so it will be basically the weight of 1 cubic meter of cargo, which is determined by the nature of cargo, what type of cargo it is. Okay. Now, if I take the reverse of it, inverse means I take 1 upon density. So in this case, what will this become? This will become 1 upon 0.9, and in denominator you'll have tons per cubic meter. I'm explaining it, you don't have to write that many steps. You'll just be using a formula at the end. And if I divide 1 by 0.9, it gives me 1.111. And this units, because it is in the denominator, the units will become cubic meter per ton. Do you agree with me, guys? Yes or no?
Yes.
You don't have to learn this. This is called a specific volume. You don't want to learn it, it's okay. That's fine. I have no issues. There is a term for it as specific volume. What does it mean? That if I take 1 ton of cargo, that will occupy 1 point, let me take it 1.1 only. That will occupy 1.1 cubic meter of space. That will occupy 1 cubic meter of space. And this depends on the nature of cargo. So whether that cargo is lying on your table, lying on the floor, lying on the road, if you have 1 ton of cargo, notwithstanding the shape, it may be cuboidal, it may be irregular, it may be regular geometric shape, whatever be the shape, 1 ton of cargo will basically occupy 1.1 cubic meters. Do you agree with me, guys?
Yes.
Yes or no?
Yes.
Correct. Then what is the stowage factor? In ship, we say the stowage factor. Let us say the stowage factor of the same cargo on the ship is 2.3 cubic meters per ton. That means when this cargo is loaded on the ship, it ends up occupying 2.3 cubic meters per ton. Each ton of it occupies 2.3 cubic meters. Now you will say,
Yes.
sir, how something which was occupying 1.1 cubic meter for 1 ton, how does it suddenly becomes 2.3? It does not physically occupy 2.3, but there is some space lost because of the shape of the cargo versus shape of the compartment. Then you have the shape of the compartment, then you have the side frames, you will have the battens. So there is something called as broken stowage, which you already know. So when on the ship it is placed, it ends up occupying 2.3 cubic meters per ton. Out of this 2.3 cubic meters per ton, 1.1 cubic meter is actually occupied by cargo. The remaining 1.2 cubic meters is broken, is lost, is the space lost. That is your broken stowage. Correct, beta? Do you agree with me what I have explained?
Yes, sir.
Yes, sir.
So out of 2.3 cubic meters, then we use unitary method. Out of 2.3 cubic meters, 1.2 cubic meters is free space. Why? Because 1.1 is occupied by cargo, 2.3 cubic meters is the free space. And this free space will be available for the water to occupy. So out of 2.3 cubic meters, 1.2 is free for water to occupy in case of bilging, is the free space. If it is 1 cubic meter, then it will be 1.2 cubic meters upon 2.3 cubic meters. This gets cancelled. If it is 100 cubic meters, then it is 100 and becomes percentage. And whatever you'll get here is the permeability basically. If you divide 1.2 by 2.3 multiplied by 100, it becomes 52.2%, rounded off to 1 decimal place. This becomes the permeability for this particular case. Do you agree with the explanation, guys? Then I'll give you the formula straight away. Those of you who want to just remember the formula can remember. Those who have understood can also, if they forget the formula, can
Yes, sir.
use this logic.
Understood. Understood,
Okay.
sir.
Yeah, okay.
Broken storage
Then,
with
so
storage
what is
factor.
permeability? Permeability in percentage will be equal to stowage factor minus, what did we do? Stowage factor minus 1.2. So 1 upon density or RD, whatever you want to say, divided by stowage factor multiplied by 100. This is what we have used here. If you see in this formula, 1.2 came as 2.3 minus 1.1. So if I put here, stowage factor was 2.3, 1 by density, 1 by 0.9, divide by stowage factor into 100 will give you same 52.2%. So this is the formula you can directly use for calculating permeability if you are given the density or RD of the cargo together with its stowage factor and the permeability is not directly provided in the question. Guys, please review it. Let me know if there is any concern, because tomorrow a question comes, you do bilging so thoroughly, you're master of bilging, you know KB, PM, everything you know, but unfortunately they don't give you permeability, they slip in this information and then you will be stranded. Entire bilging will go down the drain because you don't know how to get the permeability. So please make sure you write it down somewhere at an important place so that before the exam, if you have not understood how this has been worked, you are at least able to learn the formula and execute the process. Guys, please review it well. Let me know if there's any doubt. I'll hold here for about 15-20 seconds to address any doubts. And once you know the permeability, then the question becomes same as what you did yesterday, how the permeability was used. Then it will be used the normal way. Peter, any questions on permeability calculation? Okay. Don't worry, whatever comes on the slide, I've already explained you in ample details. There may be things which I may have put down for people to explain. I have done all this and that's the formula, so don't worry about it. Permeability will be equal to stowage factor minus 1 upon density, which is 1 upon density is called a specific volume, if you just for curiosity's sake, upon stowage factor into 100, and this will come in percentage. You can put a percentage sign here, this will be percentage, okay? Can I continue if there are no doubts, guys, on this one? It has happened in the past, but it has come in the questions a few times in the past. If you go in the historical papers, they have given the stowage factor and density and they have not given the permeability, okay? So it's not that it has not happened, it has happened in the past. So be wary of it. Can I go to continue with the next issue then? What are the add-ons to what we learned yesterday?
Yes, sir.
Okay. Now, just for the sake of practice, would you like to calculate this? A hold contains cargo of RD 0.8, stowage factor 2, calculate permeability. Just calculate on your calculators and see you're getting 37.5% better. Just practice this. let me clear the formula so that now you pick up the formula from your registers. Please just execute
sir.
this question and see
37.5.
that the answer is matching 37.5% beta. This. Please calculate the permeability and see. Please confirm if the answer you're getting beta. 37.5%.
Yes, sir.
Yes, sir.
Okay, so that means now having done this bit of step, you should be okay with the getting of the permeability. Okay. Now we go to the next one then. Now we come to a very, very special situation, beta. And such questions have also come in the past. So you need to be little careful. What we did yesterday, let me explain what is the issue coming up in this. What we have done until now is a case like this. What was the case? Case was you had a midship compartment. The vessel was floating at WL, whatever the draft D. And then either there was no horizontal deck in between from keel to upper deck, or if there was a deck like DB, if there was tank top like DB, this was below W1 L1. After the sinkage, whatever the level came, it was well below this, right, beta? Correct? These are the questions we have done yesterday. Correct, guys?
Yes, sir.
Yes,
Now,
sir.
in this question, what was not highlighted intentionally yesterday to avoid creating confusion is if you see what we have done until now, then you will appreciate that water plane area in bilged condition between WL and W1L1 is identical in all the cases. That is why you said regained buoyancy was equal to intact water plane area multiplied by sinkage. That's why you said this. Therefore, yes or no? In all questions that you have done until now, what was happening is that you were sure that the water plane area from WL to W1L1 was identical, and therefore we proceeded the way we did the other day. Now you'll say, sir, then what are you talking about? What can be the difference? Now, suppose I give you this question here. Vessel has a length of 100 meters, breadth of 20 meters, floating at 6 meters even keel draft, our standard ship. Our hold is midships, length is 30 meters, breadth is 20 meters. And now I tell you, I increase the height of this DB, and I don't call it as DB. I say there is a watertight flat at a distance of 6.5 meters, at a height of 6.5 meters. That means now the water flat is not like the DB tank top, which was just about below the water line. Now the watertight flat comes somewhere here so that this H becomes 6.5. Now, can you appreciate firstly the difference between the two situations that I'm talking about, Beta, before I take you through as to how we'll address? Do you understand what difference am I talking about vis-a-vis the questions done yesterday? Have you understood that?
Yes, sir.
Yes, sir.
Yes. Yes, sir.
So in the situation that I have created now, when the vessel experiences sinkage, based on the lost volume, lost buoyancy, I do not know whether W1 L1 will be below the flat, will it be in line with the flat, or will it be above the flat? All the three situations can happen, na beta? The final
sir.
water line after sinkage, unless I calculate, I cannot be sure with certainty whether the final water line is below the watertight flat, in line with the watertight flat, or it is above the watertight flat. Have you understood what is the problem we are facing now?
Yes, sir.
And hence I cannot draw the W1 L1. And if I cannot draw the W1 L1 without knowing where it is to be drawn, then I cannot visualize the water plane area in the bilged condition. And if I cannot visualize the bilged condition water plane, I cannot solve the question. So in such questions, you can read the title on top of the slide. This is the question where there is a watertight flat above the initial water line. There is a watertight flat above WL and is reasonably close to it, which puts you in a fix whether the final water line will be below the flat, in line with the flat, or above the flat. Please have a quick silent recap of the problem. If you have any doubts about the problem we are facing, then let me know first because it's important that you first understand the problem. Then we'll solve the issue. Then we'll address the issue. Is the problem understood, guys? So in such questions, we'll have to do some verification, some check about where the final water line is. And that will basically introduce something at the onset. You will not be able to get D1 the normal way that you learned. You will have to be a little careful in such situations. Let me take it through an example and also explain you the process of addressing it through the example itself so that we'll have the values rather than hypothetically talking about it. A box-shaped vessel, 100-meter long, 20-meter wide. Same standard ship, guys. Is floating at an even keel draft of 6 meters. Has a midship compartment, 30-meter long, 20-meter wide. It has a watertight flat. Let me use a red marker just to highlight the flat. It has a watertight flat at a height of 6.5 meters. So H, instead of 2 meters as was in DB, now becomes 6.5 meters. Okay, calculate the GM of the vessel after the cargo space below the watertight flat is bilged and the permeability of the space is 60%. So that means there is something here which reduces the free space and the permeability is 60%. Guys, is the question clear? The question is clear, beta. The diagram is as per the question. In all these questions until now, what we were doing, we were bindas drawing W1, L1 and proceeding. Now I'll hold back W1, L1. Okay. Guys, what is the first shade, the lost buoyancy? I'm sure all of you would agree that this will be the lost buoyancy up to 6 meters draft. So what do? I calculate the lost buoyancy. which in this case is LBD into permeability, which will be 30. Can you somebody keep the calculator handy, beta? 30 into 20 into 6 into permeability is also 0.6. So how many cubic meter is the volume that we have?
2160.
2160 cubic meters is the buoyancy lost. Guys,
Yes.
anybody who does not agree with the buoyancy lost, let me know. You should not have problem with these basic issues. Now, what will we do? We will calculate the buoyancy regained if the vessel sinks up to the watertight flat. That means the vessel sinks by 0.5 meters up to the watertight flat. And I'm sure you'll agree that now see what I'm doing here. Water plane area up to watertight flat. And of course, we are talking of after bilging. Water plane area up to the watertight flat after bilging. That means from WL to watertight flat. I'm sure you will agree that there will be a loss of water plane up to that, right, guys? With permeability, of course. Guys, do you agree this will be the shape of the water plane from WL to 6.5 meter draft? Yes or no?
Yes, sir.
Anybody in the class who does not understand this, please let me know, beta. So now, how much will be the buoyancy regained up to that? So what are we going to do now? Intact water plane in this water plane area multiplied by 0.5. So now, what am I saying? Buoyancy regained up to watertight flat will be equal to intact water plane area, which is from up to watertight flat, that will be whole water plane, that is LB minus lost water plane, LBP, multiplied by 0.5y, because the sinkage would be 0.5 from 6 meter draft to 6.5 meter draft. That will be equal to 100 into 20 minus 30 into 20 into 0.6, and then full thing multiplied by 0.5. How much does it come, bete?
1020.
Guys, 1020 cubic meters. Can somebody
Yeah.
check and validate before we make a mistake, beta? Is that correct?
Sorry, 820.
820 आएगा सर 820.
820.
820, okay. 820, okay. Now, guys, how much have I lost? I have lost 2160 cubic meters. How much I need to regain total? I need to regain 2160. Now, suppose, now this is hypothetical. Suppose the answer here was 3000 cubic meters. That means, where will your final water line? It will be below the watertight flat. Yes or no? If it was 3000 cubic meters, correct? Guys, I'm asking you, if the buoyancy regained up to watertight flat in our calculation, had it come 3000 cubic meters, what will it signify? It will signify that your final water line will be below the watertight flat. Yes or no? Correct?
Yes, sir.
Yes, sir.
If it was exactly 2160, it shows that your final water line is lined with the watertight flat. Correct?
Yes.
But what have we got? We have got 820 cubic meters. That means 820 cubic meters is regained up to the watertight flat. The balance will be regained above the watertight flat, right? So balance to regain will be equal to 2160 minus 820. I am yet to regain this 1340 cubic meters, right, guys? Yes
sir,
or
correct,
no?
sir. Correct, sir, correct.
Now, above the watertight flat, what will be the shape of the water plane?
Sir, rectangle.
It'll be rectangle, but it will be fully intact, right?
Fully intact rectangle, yes, sir.
Above watertight flat. So whatever the sinkage takes place above the watertight flat, for that sinkage, the water plane area will be fully intact. Correct, beta?
Correct, sir.
You'll see the bulkheads, but you'll not see any water.
Water, yes, sir.
So sinkage beyond 6.5, sinkage beyond 6.5 meters, beyond H. Why? Because 820 is already regained up to H. I need to regain 1340 more. It will be the buoyancy to regain upon intact water plane. Now here the intact water plane is full, so it is 100 into 20. So this becomes how much, beta? 0.670 meters. Am I right?
Right.
Yes,
Yes, sir.
correct. So your total sinkage in this case will be 0.5 meters has taken place up to the watertight flat. Another 0.670 will take place beyond that. It will be a total of 1.170 meters. You can see this sinkage matching with here. The total sinkage will be 1.170 meters. This step gets added. This is an additional burden in the exams.
सर ये वाला लाइन क्यों करेंगे सर?
कौन सा बेटा?
ये जो अभी आपने सर सिंकेज बैंड 6.5 किया है, हम तो 6.5 से नीचे ही तक है ना सर, जो मेरा हो रहा है, तो हम इसको क्यों करें?
अरे 6.5 से नीचे बिल्जिंग हो रहा है, रीगेन तो उतना करो। वो सिंकेज तुम्हारे हाथ में थोड़ी है। बिल्जिंग is happening up to water line. Your lost buoyancy is up to 6 meters, but how much will you sink will depend on how much have you lost now. That is not in your control. Yes or no? You have to regain that much, correct?
सर मेरा तो सर buoyancy 820 आया ना सर, तो मैं 820 का ही सिंकेज से सर निकाल।
कब आया buoyancy lost to 820? What is this 2160?
That is total buoyancy loss.
That is the buoyancy loss, no?
Yes, sir.
So तुम 820 क्या कह रहे हो? What is 820? Look at the slide and look at your working. What is 820? Please correct yourself.
Okay. Yes, sir. Yes, sir.
What is 820? Speak out. Speak out, beta. Don't go into silence. What is
820 is the buoyancy loss only for the 0.5 meter.
No. 820 is the buoyancy regained up to watertight flat. Speak correctly. Otherwise, you'll not be able to recall properly. You lost 2160. The vessel has to sink to regain 2160. Now, the watertight flat is 0.5 meters above the WL. In that portion, the intact water plane is the whole water plane minus the lost water plane. So for that 0.5 meters of sinkage, how much do you regain? You regain only 820 cubic meters if the vessel sinks up to 6.5 meter draft. Correct, beta? That is the H.
Yes.
The moment you reach that, after that, your water plane becomes fully intact. It becomes like a DB of 6.5 meters height, right? And how much do I need to regain beyond that? That is the balance. That is 2160 minus 820. So if 1340 is what I need to regain above the flat, Now, above the
Hmm.
flat, the full water plane is intact. There is no loss of water plane above the flat, right?
Yes, sir.
So full is intact. So I divide by the full intact water plane and I get the sinkage after 6.5 meters. Sinkage after the watertight flat, correct, beta?
Yes, sir. 0.670.
So you have already sunk 0.5 meters to come to watertight flat, and then you are further sinking by 0.670. So the total sinkage is how much?
1.170.
Okay. Have you understood now?
Yes, sir. Yes.
Sure, Pakka?
Yes.
Guys,
Sir, one question.
probability of such questions is higher. Let me just tell you this. So if you
Sir,
tell me, beta, what is the question?
sir, if lowest buoyancy is exactly 2160 और सब
Then it
उस
will be
टाइम
in
पे
line with the watertight flat.
नहीं नहीं सर
And then
मेरा
what?
क्वेश्चन है
Then the plane will be intact. Plane will be intact. That is your
हाँ
question.
that is my question. Yes sir. So जो उस
Plane will
टाइम
be
पे
intact, na beta. Because if you cut there, you'll see the tank top. You'll not see the water.
okay sir, exactly if lowest buoyancy is same then intact water plane. Thank you sir.
Yeah. So final water plane at that line will be intact, fully intact. Okay.
कॉपी सर क्योंकि ये एक बार आ चुका है उसमें प्रीवियस एमएमडी क्वेश्चन में सेम था तो कई लोगों को ये
बेटा
क्वेश्चन
my question is, मैं वही कह रहा हूँ ना, अगर तुम if you cut the ship at 6.5 meters, you are not going to cut the flat, and if you move from the top, you'll see the watertight flat. Yes or no? Correct?
थैंक यू सर फॉर
Okay.
क्लियरिंग सर अंडरस्टूड सर.
Okay, guys, any more doubts? It's an important thing. It's a very, very important part of this particular discussion that we had yesterday and today. And once you know this, then you know you can draw the water line W1, L1 here,
Sir,
and then
अगर
the question becomes simple.
sir,
Then
sorry
W1,
sir.
L1 is, yeah, tell me.
Sir, if the watertight flat के पास same height में अगर ये होगा sir buoyancy होगा, then what will be the overview plane view sir from top?
It will
Then
be
also
fully
we are
intact.
not
It
able.
will be fully intact, beta.
Okay.
This is what the question was somebody asked before you, no? That was the question he was asking, beta.
Okay.
So, guys, please review it. It's a very important component of this GM calculation because these questions have come in the MMD, and if it is GM, there is every possibility that they may use such questions out there just to, engage you a little more. Anybody who needs any part to be explained again, what I'll do is I will clear it off, and together with you, I will solve this full question now. I will not leave it here for you to do because otherwise some of you may get lost about as to what is done and how do we close it out. So let me close out this question, and those of you who want to close out ahead of me can do that. I have no issues. You can keep checking your working. So if you know, you can close out, and if in fact every one of you should close out and then use it as a tool to validate. That will be a better way to learn better. Okay. I'll clear this and I'll draw the diagram again so that there is no mixing up here, and then I'll solve the question with you. And anybody has any problems, please interject then and there itself. So don't worry about there's no disturbance, no distraction. You can always ask your doubts. Okay. First, we make the diagram, which again holds the key. Length 100 meters, breadth 20 meters, floating at an even keel draft of 6 meters, has a midship compartment 30-meter long, 20-meter wide, with a watertight flat at a height of 6.5 meters. H is equal to 6.5. This compartment has some solid content, cargo or whatever, of permeability 60%, 0.6. Okay, this is the diagram. Now the problem is I'm hit with a watertight flat which is above WL. If it was below WL, then there was no concern. If it was not there, then there was no concern. Problem is, I'm hit with this problem now. And so I'll have to first calculate the lost buoyancy. Lost buoyancy would be this shaded up to W1, L1. Okay. Now, what is the lost buoyancy? Lost buoyancy is equal to, write like this, guys. If you write like, look at the diagram, and the diagram says it's LBD. Put the values 30 into 20 into 6. This is 120. 30 into 6 into 0.6. Sorry, my mistake.
Permeability, sir.
Yeah, into 0.6, my mistake. So it came to 2160. Am I right? How much was it?
Yes, sir.
Yes, sir.
2160 cubic. So this is the first step, beta. Now, I draw the water plane in bilged condition up to watertight flat. And I'm writing what you should write. And then I'm drawing this water plane here, guys. And up to the watertight flat, the water plane would be lost. You can put the dimensions L, B, and permeability. Okay. So next line, buoyancy regained up to watertight flat will be equal to intact water. Now I'm just talking to myself and solving it. Intact water plane. Intact water plane will be whole water plane minus lost water plane into sinkage from 6 meters to 6.5, that is 0.5. I put the values 100 into 20 minus 30 into 20 into 0.6 into 0.3, 0.5, sorry. And I think you said 840 or 860, guys. How much?
820.
820.
Cubic meters. Okay. Okay. So now you can compare it with here. You can compare with 2160. You know the buoyancy regained is less. So the vessel has to sink. If you want, you can write here, no problem. As buoyancy regained up to watertight flat is less than buoyancy lost, vessel shall sink beyond watertight flat. Okay. You can write suitably worded here. If you want to just say that I have compared. Okay. Now, buoyancy to regain above watertight flat will be equal to 2160 minus 820 is 1340 cubic meters. Now you will come here. Water plane in bilged condition above the watertight flat. And now this will be fully intact. Length 100 meters, breadth 20 meters. You'll see the bulkheads, but you'll not see any seawater out here. So, therefore, sinkage beyond watertight flat will be equal to buoyancy to regain. Speak to yourself full. You can't keep writing everything in statements, otherwise you'll never be able to close the paper. Talk to yourself. Buoyancy yet to be regained 1340 and divided by the intact water plane for this regaining depth, and you look at it, it's 100 into 20. So this is 0.620. Am I right? 620, no, beta? 0.67, is it? 0.67, right? Okay. Therefore, you can go instead of total sinkage, you can find D1, no problem. Therefore, D1 will be equal to 6.5 plus 0.607 equal to 7.170 meters. Please confirm if the calculation of D1 is clear to everybody.
Yes, sir.
I take a pause here before I continue with the question for any doubts, because this is the new step which has got added to. Now the question will be straight, we can run away with the question. Okay, now what we'll do is, we will draw the water line, final water line. We know it's going to be above the watertight flat. This is where I draw W1, L1, and this is my D1 equal to 7.170 meters. Guys, KB shall be by moments. Why? Because up to the watertight flat, there is a loss of water plane. Above the watertight flat, there is no loss of water plane. Does everybody agree that KB will be by moments? Anybody has any doubts that it can be D1 by 2? Let me know. Does everybody agree KB will be by moments, guys? Yes or no?
Yes, sir.
Okay. Now, my I is on the diagram above. KB final will be equal to, I'm talking to myself, vertical moment of underwater volume about, so that is LB D1 into D1 by 2 minus the vertical moment of the underwater volume not contributing to buoyancy, that is this one where I have drawn the blue box. So that volume is LBD into P, and its distance from the geometric center will from the keel will be h by 2, 6.5 by 2 divided by LBD, and when you put the values 100 into 20 into 7.170 into 7.170 by 2 minus 30 into 20 into draft 7.170. No, sorry, my mistake. Yeah, LBD, yeah, LB. One second. LB minus LBH. Sorry, not D. It is H. My mistake, guys. In the formula, it is H. Okay, you didn't correct me. You should have done that. 6.5 into permeability of 0.6 into H by 2 is 6.5 by 2. Am I right, guys? Am I right? This is the underwater volume. The blue box volume is how much? LBH into P. Yes or no, beta? Correct? Am I right, guys? Please correct me if I'm wrong. Divided by volume of displacement, 100 into 20 into 6. And this should give you a KB of 3.650 meters. I again take a pause here for anybody to. Now it has become a question like DB actually. Now it has become like double bottom question. Only thing is the height of the double bottom has become 6.5. Okay, let me know if there is any challenge about KB. Don't worry about the calculations. Look at the presentation, look at the formula. Everybody good about KB, beta?
Yes, sir.
Okay, I'll be there on the next page also if anybody has any doubt, no problem. Let me split screen and go to the next page, take it to the next page. Let me keep it here and go to the next one then. Okay. Okay, I'll come here then. I think I'll use this space rather than that way. Okay. So here is the working that we have done. If anybody has any doubt, you can see it here also, and let me know if there's any concern. All good up to this point, beta? Okay. For BM, I don't have to draw, but since I have overwritten it, I'll redraw this part again here. It was not required to be drawn again because it is already there. But since I have overwritten it, that's why I'm drawing it. Let me use green now. So what am I drawing? Okay, let me draw here. Water plane in bilged condition at W1, L1. Okay, guys. The full water plane at W1, L1 is intact. So BM will be equal to I, where will be the center of flotation here? 4.5 axis will be center line. ICL of intact water plane upon volume of displacement, it will be equal to LB cube by 12 divided by volume of displacement LBD. It reduces to B square by 12D. B square is 20 square by 12 and D was 6. How much is the BM? 5.556. So now you have the BM, you have the KB, and you can get the GM. So GM will be equal to KB of 3.650 plus BM of 5.556 minus the given kg in the question, and the answer should be 1.706 meters as the GM after bilging. Please have a good look at the full questions on the screen now, even what we are worked on the previous slide. Have a good look at it. How to write, how to present. I have put every step there. If you want to clarify anything, let me know. We are just building on what we learned yesterday, beta. Now we are bringing in some intricacies or some complications which they put for exams, and those are the issues we are now going to trying to build on the actual process that we learned yesterday. So it is nothing new. It's only addition of little bit here and little bit there just to address the special situations or special conditions.
सर जस्ट एक छोटा सा डाउट लगा ये
हाँ,
सर
बोलो।
वाटर टैंक के ऊपर जो हमारा आ गया है सिंकेज जिसके कारण इंटैक्ट पूरा हमारा वेसल इंटैक्ट दिखता है दैट्स व्हाई बीए में आपने पूरे वेसल का एक साथ में
यस
कैलकुलेट कर लिया
जैसे डीबी में करते थे बेटा, डीबी में भी तो अभी इसको डीबी में भी तो फ्लैट होता था नीचे. You had the it becomes like DB of 6.5 meters high now after bilging, correct?
Okay. Means जो था वो एक DB बन गया. That's why we don't have any concern with that one to calculate the BM.
I will not say that. I would visualize the water plane. I will still repeat the same thing. I would not make such loose statements that we have nothing to do with it now.
Okay, understood.
So don't make such loose statements. You have to. Your question has to be why the water plane is intact. So that I can answer, but I cannot say forget about it.
Okay. Understood.
Guys, is that clear? You'll be able to address it if it comes in the exam now. Such question.
Sir, small doubt.
हाँ बोलो.
Sir, as we got loss buoyancy 2160 And
Yeah.
let's say buoyancy regained was more than that, as you explained earlier, 3000 agar aata, if in case, in some
So
case.
that means your water line is below the watertight flat. Then watertight
Below the
flat, whether present or does not present, does not make a difference, no?
That's my
Then
question,
then
sir.
then,
If
then,
it-
then 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 it becomes like the first question that you did yesterday
First question
without any
only.
flat,
Okay, fine. Okay, fine. That's what it was. Thank you.
right?
Yeah.
Then you okay. No. Anyway, let me address this. I'll draw that also and show you the line. Not this question. I'll just draw a diagram and talk to you. Guys, is that clear to everybody? Okay. If there are no doubt, then I will just draw a diagram to address what some of them are, you are saying. The other two cases which possibly could be there, of course, they will not apply to this one. Let me clear this one here. I'll keep the other one and delete this one then. Okay, what people are saying is that is not related to this question. Okay, it's not related to the question. Let me make a diagram here, a bigger diagram. Okay. Okay. This is my initial water line WL. This is my watertight flat. I'm putting it little higher. Okay. This is H. Now you are saying if the buoyancy regained up to watertight flat is greater than the buoyancy lost. That is what you're saying, right, guys?
Yes, sir.
Correct? So in
Yes,
that
sir.
case, yeah, in that case, whatever the values be, values are immaterial. In that case, my water line will be somewhere here. I can draw it anywhere below the flat. This will be W1, L1. Now, this flat is immaterial. This has no relevance now, as far as our calculation is concerned, right? It becomes irrelevant. Understood?
Yeah, yes, sir.
If it was, now you can solve it. No, if W1, L1 is drawn here, then your interest is only up to W1, L1. Your interest, this is of no interest to you, right?
Yes, sir.
Your
Just like
interest is
initially.
only up to W1, L1, right, beta?
Yes, sir.
Okay, then you can solve it, correct?
Yes, sir. Please.
Okay, fine. Any more questions, guys? Here is the question. If you still have anything, the full question is here on display. So we have addressed two issues today. Please make a note of them somewhere before you miss out. One, if the permeability needs to be calculated, you need to learn that formula if you don't want to reason it out. Second, if you have a watertight flat, which is above the intact water line, but in close proximity, and then you can't figure out where the final water line after bilging would be, then D1 has to be calculated the way it is on display right now. And then you'll take a call and draw W1, L1. Am I clear, beta? Am I clear, guys? Okay.
Yes, sir.
We go to the next issue then. Guys, most of the textbooks and most of the people talk of a topic called as bilging of midship compartment. Okay, we have also built midship compartment until now because we did not want other doubts to surface during the discussion. Okay. And then what do you calculate? You calculate GM. And then somewhere a student tends to believe that bilging of GM compartment, the calculation of GM is only applicable to bilging of the midship compartment. Okay. So the way the exercises have been framed and the way it is taught, if you see, I have not used anywhere the word bilging in the title, bilging of midship compartment. I kept the compartment midships, but I did not say bilging of, we are doing bilging of midship compartment today, guys. No. I kept my compartment midship, I continued, never mind. But I never emphasized upon that we are only restricting ourselves to bilging of the midship compartment. So this should not put a wrong impression in your heads that GM calculation pertains only to bilging of midship compartment. Okay. Now please understand, though your ship stability has three components. Your stability has three distinct components. One is called the static stability. What is the measure of static stability? GM or GZ are the measures of statical stability of the vessel. Second is the longitudinal stability. Trim is the measure of vessel's longitudinal stability. Third is the transverse stability. List or heel, here you can say trim or pitch, they pertain to longitudinal stability. These are the three components. The ship stability can be divided into three distinct components. All the three components, when be it static, longitudinal, or transverse, all the three components of stability are equally important. You can't say, I can be stable, keep my GM high, but longitudinally, I try to sail out with adverse trim and have all those issues. So stability, all aspects are important. But how are they calculated? They are calculated independent of each other. When you calculate the GM or GZ, you do not care whether the vessel has a trim or not. Okay. Yes, we do factor in GZ, but in GM, the list also is not factored, right? When you calculate the longitudinal stability, that time you do not worry about the other two aspects. And likewise, when you calculate the list of the ship, you do not worry what is the trim. So what I'm trying to say is all these three components of the stability are calculated independent of each other. Now, if you recall your MV Hinship questions, suppose you are loading some cargo in number one hold. Suppose the ship was floating at 10,000 tons displacement with a kg of 7 meters. Okay. And now you load 1,000 tons in number one hold. Then what happens? The displacement becomes 11,000 tons. Now, have you done such questions that after loading find the GM of the vessel? Yes or no? If I say MV Hinship is floating at 10,000 tons displacement, kg 7.5 meters, 1,000 tons is loaded in number one tween deck, calculate her GM after loading. Can you all calculate? Yes or no?
Yes, sir.
But will the
Yes, sir.
GM change the trim also? Yes or no?
Yes, sir.
Yes, sir.
So that means any loading, whether it is done at the forward end, it is done amidships, or it is done at the after end. It may change trim, it may change list, but it will also have an effect on GM. So we should not just tune our minds that GM is required only if the bilging is of a midship compartment. Tomorrow somebody gives you a bilging of a compartment at the end or somewhere else and tells you to calculate GM, you should not start getting up in the MMD hall and saying the question is wrong. Please don't do that. The question is very much right. It is because we are programming our minds wrongly, and that's what actually leads to the problem. Okay. So I'm just warning you that there can be the GM question can be required to be calculated even when the vessel, the compartment bilged is not amidships, and that is what this topic is. Okay, so let me just take a question here. Okay, it's here. A box-shaped vessel, 190-meter long, 25-meter wide, is at even keel. I think somewhere, I don't know, it's MMD question or Dubey's book or somewhere. I must be MMD because I would have picked up from there. I may have modified here and there a little bit by taking it the forward end, A box-shaped vessel 190 by 25 is at even keel draft of 8 meters. So let me make the diagram. Length 190 meters, breadth 25 meters, is at an even keel draft of 8 meters. Same notations, we stick to same notations time and again. kg 8.6.823. It has a compartment at its forward end. So let's say this is the forward end, suppose this is the aft end. So there is a compartment at the forward end, okay? It can be somewhere in between also, need not be right at the end also, okay? Which is 15 meters long and divided into port, center, and starboard. Port and starboard compartments are 6 meters wide each, and center is 13 meters wide. Calculate the GM of the vessel if only the center compartment is bilged. So I will take only the center compartment first. For center compartment, the breadth is 13 meters. So I'm making the diagram pertaining to part A, guys. Breadth for center compartment is 13 meters, that is bilged. And this will cause the vessel you will lose this much of buoyancy. I think somebody has already raised this question in one of the earlier classes when I said normal stability calculations we always do for upright even keel condition. Correct? You remember, guys, the statement being made earlier? Yes or no?
Yes, sir.
Normal stability conditions will work for even keel upright condition. Okay. So what I have shaded is the lost buoyancy. This will cause the vessel to sink to a new waterline W1 L1. I do not care whether she trims or not. I make my waterline like this. Only thing is when I calculate D1, that will be the high draft. That will not be the draft everywhere, that will be high draft. So it doesn't matter. What will happen? The water will rise in this part here. Okay. Now I make the water plane area at W1L1. The water plane area at W1L1 in the bilge condition will be like this. The length of the water, whole length will be 190 meters. Whole breadth will be 25 meters. And then you have these compartments which are divided into port, starboard, and center. Each one of them is 6 meters and 6 meters, and this is 13 meters. And since only the center compartment is built, so now I can show it here like this. Length of this compartment is 15 meters. Guys, do you agree with the diagram for part A now, or anybody has any doubts? Tell me. Please review the part A of the question and see is the diagram correctly made, or do you have any doubts to clarify?
Correct.
Guys, everybody is convinced with the diagram? Class, everybody is happy with the diagram, bete?
Yes, sir.
After we finish this question, I'll give you break. So don't lose heart. Don't lose heart. I'll give you break after the class. Okay. So now we do the same thing. First, we find sinkage. Sinkage will be equal to lost buoyancy. I have my eye on the upper diagram. The lost buoyancy is LBD. Divided by the intact water plane area, I have my eye on the lower diagram. It will be LB minus LB. Permeability is not given, no, I'm sure. It's not there, okay. So this will be equal to length is 15 meters, breadth of the center compartment is 13. You see, I've written the breadth 13 here. Please be careful. Into draft of 8 meters upon 190 into 25 minus 15 into 13. Can you please calculate and give me the sinkage, guys? And anybody who does not agree with this representation, let me know. You can raise your doubt as and when you have that coming to your head.
The 0.342.
Okay, 0.342. Yeah, sinkage is given here in the answer. I've given it for you to check at each step. 0.342, right, guys?
Yes,
Therefore, D1, the height draft, will be equal to 8 plus 0.342 equal to 8.342 meters. You can mark it wherever you want. It doesn't matter because I've drawn a horizontal line. You can mark it here. You can mark it after it also. It doesn't make a difference because as long as the water line is drawn plane, it's okay. What it means is the height draft, even keel condition draft. I know there'll be she'll go down by head when you get bilged like this. Okay. Now, look at the diagram, upper diagram, and tell me whether KB will be D1 by 2, yes or no.
yes,
There is one yes. Anybody in the class, yes or no? Others?
Yes, sir.
Yes, sir.
Two, yes, okay, very good. So KB, so you'll write as the water plane. So let me write as the water plane in bilged condition is identical from keel to bilged water line W1 L1. AB will be equal to D1 by 2, that is 8.342 by 2, that is 4.171 meters. Am I right, guys? Yes or no?
नहीं आया इसका समझ।
yes,
Correct, Peter? Okay. Now, guys, look at the lower diagram, water plane area diagram. Do you think center of flotation will lie on the center line? Yes or no? Whether it lies at the forward or aft end or midship doesn't matter. Does it transverse location, athwartship location? Is it going to be on the center line? Yes or no?
Yes, sir.
It is going to be on the center line. While you see, when I draw the center line, the area on both sides are symmetrical, right? The lost area,
Yes, sir.
intact area is symmetrical about the center line. So center of flotation will be somewhere on this line. Yes or no, guys? Am I right? Correct, Vite?
Yes, sir.
Okay.
Yes, sir.
So BM will be equal to ICL of intact water plane upon volume of displacement. ICL of the intact water plane will be equal to ICL of the whole water plane minus ICL of the lost water plane divided by volume of displacement. ICL of the whole water plane is no issue, LB cube by 12. Tell me, is center line a standard axis for the lost water plane? Yes or no? Is center line a standard axis for lost water plane?
Yes, sir.
Yes. So then it will be minus LB cube by 12 divided by LBD. So now it is 190 into 25 cube upon 12 minus 15 into 13 cube by 12 divided by 190 into 25 into 8. And if you solve this, you should be getting a BM of, answer is there on top, 6.438 meters, unless I have made any mistake in the expression.
yes, sir, right. 6.438.
Okay. And then this gives you the GM of 3.786 meters. You can calculate and see whether the GM is 3.786 or not.
Yes, I think sir 6.43.
Please review it. We have calculated the GM of a vessel after bilging when the bilged compartment is not located amidships, but working has not changed. Working has not changed. It has remained the same. Only thing is, it can just be unnecessarily confusing if you are not familiar with this.
GM
It
is
can just
3.785.
बेटा ये आंसर मेरा गलत है क्या 3.786 या okay 8586 is okay.
Yes,
That's fine.
sir. Yeah.
86 आ रहा है सर, ठीक है.
86 आ रहा है ना, that's okay. Okay, guys, is this part clear to everybody that compartment was not amidship? So don't always be under the impression that the question should be when if it GM is asked, it should be only amidship, nowhere else. Otherwise, you will just be struggling, and some of you will just be after the invigilator saying the question is wrong. Question is never wrong. Guys, if you're done with part A, can I go to part B?
Yes, sir.
Okay. बड़ी जल्दी डाउट आया तुझे यार? क्या बोलूं मैं तुझे? What should I tell you? When will the G shift? Tell me. When does the G shift? When does G shift? That is my question, not forward aft. When does G shift? Center of gravity shift.
And adding, loading, or moving away.
Okay, so have you under lost buoyancy method? Are you doing any of these things? No. So why will G shift? And if G does not shift, it's not only kg, even the LCG will remain unchanged. Okay. ये तो कल बात हुई थी भाई, किधर चले जाते हो तुम घूमने बीच में, फिर पकड़े जाते हो. Even online में you guys get caught that you have missed the class, right? Anyway, chalo, let's go to the next one, so that you don't struggle with the questions. Now we come to part B of the same question. Values are here. I'll make the diagram. This has to be separate diagram, guys, for part B. Length 190, breadth 25, even keel draft of 8 meters. Forward end, aft end, compartment here. Length 15 meters. For part B, I have two compartments. Each one of them is 6 meters. So what am I writing? 6 meters into 2. That means there are two such compartments. Vessel will sink to a new water line, W1, L1. I will lose this much of buoyancy. As the vessel sinks, the water will rise here also. Does everybody agree with the side elevation or any doubts? Guys, is that clear? Side elevation, all of you agree? If you see, you must represent your diagram properly. Whether you use scale or not, as long as you have drawn reasonably good lines. And I often tell people, your diagram should speak to you. A diagram is made so that it makes your working simpler. The diagram should be communicating with you. Diagram should not be made because you have to make it just for the sake of exams. Diagrams actually help you in the solution, guys. Now I make the water plane area in the bilge condition at W1, L1. length 190, breadth 25, forward end, 2 wing tanks, 6 meters, 13 meters, 6 meters, length 15. This water plane is lost and this water plane is lost. Am I clear, guys? Is the diagram right for part B?
Yes, sir.
Only the wings are bilged. Correct, Pete? Okay. Now we find out the sinkage first. Would you like somebody to find? Answer is given 0.315. Is it coming so? Dekho. See if it's coming so. Anybody who's not getting sinkage, let me know. 0.315. Calculate and see.
Yes, sir. 0.315.
Okay. Anybody in the class who is not able to get, please don't feel hesitant. Then I'll write the steps. If you're getting it, then I need not write. Answer is already there. Anybody in the class who needs sinkage formula, sinkage expression to be written, or all are good? Okay, no request. That means sinkage is done. 0.315 meters. This gives you D1 of 8.315 meters. Okay, guys. Again, the question, how much will be the KB? Is it D1 by 2? Yes or no? Is KB D1 by 2? Yes or no, beta?
Yes,
Sir,
sir.
D1 by 2.
It is still identical from.
Okay, very good. So you'll write the same phrase here as the water plane is identical from keel to W1 L1 in the bilge condition. AB final will be D1 by 2, 8.315 by 2 equal to 4.156 meters. Correct, bete? Correct, guys? Okay. Okay, now for BM, again look at the water plane area, visualize the center line and see if the center of flotation is going to be on the center line, yes or no. Visualize the center line in the water plane area and see if it is going to be on the center line, yes or no. Tell me, is this the 4.5 axis through the center of flotation? Is it the geometric center of the intact water plane? Yes. Why? Because the intact water plane is symmetrical, right? You have intact water plane is symmetrical about the center line. So I'm sure you'll agree center of flotation will be somewhere on the center line. Do you agree or anybody has a doubt? Please let me know if there's a concern. Don't remain silent. Done, beta? So now Bm will be equal to ICL of the intact water plane upon volume of displacement. Now, guys, my questions to you are, is center line a standard axis for the whole water plane? Yes or no? Is center line a standard axis for the whole water plane? Yes or no?
Yes.
No, sir.
Center line is not a standard axis for the whole water plane. Why, better?
It is same, sir.
Somebody who said no, would you like to tell me why is it not the standard axis, beta? Is it not parallel to one of the sides or not passing through the geometric center of the whole water plane? What is the issue? Somebody who said, can he now respond, please, rather than going into silence? I'm putting questions to him and then you should respond if you're making some statements. अरे बोलो भाई, अरे लापता. Now, whom do I address? If I don't know who has the doubt, whom do I address, guys? Beta, who said no? Would you like to identify yourself? So nobody said no. Maybe I heard it wrong then, it seems. Okay. So center line, everybody agrees, is the standard axis for the whole water plane. Same question to everyone now. Is center line standard axis for the lost water planes?
Yes, sir.
No.
No, sir. There are two no's, one yes. Either the no should convert to yes or yes should convert to no. And if you still want to hold your ground, then I'll explain. Do the no's want to change to yes or yes wants to change to no? After a second thought. Okay, who said yes? Please identify so that I can talk to you by name. Who said yes, beta? यार ये तो गलत है ना क्लास में. There's no way to do the class then. I said who said yes. I am asking the name, yaar. This is the third time I'm asking. If the same question has to be put 3 times, then I think you're wasting everybody's time.
Sir, I did not say yes or no so far, but I just have a doubt that I wanted to speak. I mean, center of the water plane.
Which water plane? Name the water plane. No, you just can't say water plane. Which water plane are you talking about? Yesterday we introduced 3 terms related to water plane, right? So which water plane are you talking about? Yesterday, which 3 terms did we introduce about water line, about the water plane?
Whole, lost, intact.
Whole, lost and intact. So which water plane are you talking about? You just can't say center line is passing through geometric center of the water plane. Which water plane, bhai?
Whole, sir, the whole water plane.
So then is it a standard axis? Yes or no? Is center line a standard axis for the whole water plane? Do you agree? Yes or no?
Yes,
Yes.
sir, for the whole.
Guys, anybody who feels center line is a standard axis for the lost water plane, please speak up so that I can explain to you. Anybody who has doubt, because then don't tell me after the question that why this is being done like this.
So I said, sir, it is no.
No, you said no. I'm just asking if anybody has a doubt. But it's an open question to everybody, not you. Okay. So everybody agrees that center line is not a standard axis for the lost water plane. Absolutely right. Why?
Yes,
because it is not passing through the geometric center of the lost water plane. The standard axis for a rectangle is the one passing through the geometric center and parallel to one of the sides, either length or breadth. Yes or no, beta? Correct?
Yes, sir.
Yes. Okay. Now, one choice you have is you do by theorem of parallel axis. That means you draw through the geometric center of the lost water plane a parallel axis, XX. That is one way to do it. Second, in this case, because there is no cargo in the side tanks. A simpler way could be in this case. It is only for simplicity. If you want me to do by parallel axis, I'll do by parallel axis. So I'll check with you how you want to do. Another way of doing it, this case could be easier, could be moment of inertia about center line of this rectangle, which is 190 minus 15, plus the moment of inertia of this rectangle. You add the moment of inertia of the two intact areas because it is a standard axis for both these areas. Yes or no, beta?
Yes, sir.
Yes, sir.
Okay. So the more you learn about moment of inertia, you'll be able to see what is the simpler way to do. Now, which one you want me to apply? You want me to apply theorem of parallel axis, or you want me to do the summation of two moment of inertia? What do you want me to do?
Summation of 2, because center one already we calculated previously also, so we can add that one.
No, we cannot add. This time the bigger rectangle will have lesser side, beta. That is 175 meter long now.
Yes, sir. Bigger one we have to calculate. The center one we can take from the previously and we
Okay,
can.
okay, no, that's not an issue. So, okay, if you want me to use the theorem of parallel axis, I'll come back to that again. In this one, I'm saying this area is A1 and this area is A2. So what am I saying? ICL of area A1 plus ICL of area A2 divided by volume of displacement. Does everybody agree with this step?
Yes.
Guys, everybody agrees? This is just to avoid
Yes, sir.
use of theorem, just to avoid theorem parallel axis. That's all. Otherwise, there is no rational. This will be equal to, now ICL of A1, length of A1 is 175, 190 minus 15. This length is 175, guys. 175 into 25 cube by 12 plus the length of A2 is 15, breadth is 13 cube upon 12 divided by volume of displacement 190 into 25 into 8, and you will get a BM of 6.069 meters. So in this case, because the side tanks do not have any cargo, we could avoid the use of parallel axis. However, if it does not strike you, still want to use parallel axis, there is no offense. It's perfectly fine. That's perfectly fine. So these two are added to just save time, just to simplify our workload. Otherwise, there's no other reason better. And now you can add the KB, AM, KB, BM, subtract the kg. Are you getting the answer of 3.404? Please check. 3.404.
Excuse me, sir.
Yeah, tell me, beta.
Sir, can you please explain this theorem of parallel axis method also?
You tell me. You'll have to speak, participate, and tell me. Let me do by theorem of parallel axis.
All right.
You need to tell me. I have already drawn an axis.
Yes, sir.
Right. So now
Yes.
let me do it here only. What is the distance between the two parallel axes? Look at the diagram and tell me the value.
3 plus
6.5.
So this is x. How much is the distance?
6.5.
Sorry,
6.5.
6.5. Is it?
No, sir, sorry. 9.5.
9.5. X is 9.5. Okay. I have not used D because D we have already used in draft. Okay. So that's why I'm avoiding the use of D here. Okay. So now, beta, it will be equal to ICL of the whole water plane minus ICL of the lost water plane by volume of displacement. This will be equal to ICL of the with this thing ICL of the whole, I'm just going to simplify it here, minus 2 into ICL of one side tank, one side area upon volume. This will be equal to ICL of the whole water plane minus 2 into, now I, by theorem of parallel axis, Ixx of one area plus one area into x square. Correct, bete? By theorem of parallel axis, do you agree with me?
Yes, sir. Yes, sir.
And somebody who wanted to know about theorem of parallel axis, is that clear?
Yes, sir. Yes, sir. I wrote the same expression, but I'm
Okay,
not
very
getting
good.
the...
So now ICL of the whole will be LB cube by 12. That is 190 into 190 into 25 cube by 12. That is this expression minus 2 into Ixx of one area will be length is 15, breadth is 6 cube by 12 plus area of one is 15 into 6, 90 into x square, 9.5 square divided by LBD 190 into 25 into 8, and this will give you same answer of 6.069 bit, unless there is a clerical error somewhere.
Okay, sir. I tried it 3 times, but now it is coming 6.28.
No, it will not come 6.28. It can't come. It can't
Okay,
come,
sir,
beta.
Try it again.
Do it again. It can't. Okay, this will also be minus, na bete? Oh, sorry. When you open the bracket, this will also be minus. Bete, this will be minus. I hope this you are not taken as plus. When you open this bracket here, let me change the color of the marker. That may be the mistake you have made. Now I know what you would have done. See here, this bracket is there and this is minus here. So when you open the bracket, this becomes minus and this will also become minus, bete. Understood?
Okay,
is that the mistake you made?
Yes, sir. Yes, sir. Yes, sir.
Yeah, so that will be minus. Do it again and see whether you're getting 6.069 or not.
Okay, sir. I'll try.
And do it right away. No hurry.
Yes, sir.
And those who are not doing it, please don't be so happy, because if there is permeability in the side tanks, then again you'll have to use theorem of parallel axis. That will be the easier way. So don't try to avoid something, especially in the class. We should not try and avoid. I'm happy he took it by theorem of parallel axis. In class, we should not shy away. In exams, if we can smartly maneuver, it's okay. In class, we should sort it out both ways. So is the answer matching now, beta?
Sir, I'm still...
It will match now. It cannot be wrong.
Matching now, sir.
Yeah. Okay. Okay. Now, I'm not going to let you go. This is the question for you to do. I brought the permeability on the side tanks. Now you can't use A1 plus A2, because then you'll have so many intact areas. Now the best will be whole minus lost. Can you take down this question and solve it in the during the day, beta? Same question. I have inserted permeability on the in the spaces. So this is for you to try. This is answer to part A. Taken the screenshot of this one, part A answer, beta. Okay. Then take the answer for part B also. This is for part B, beta. Part B, GM 3.501 is for part B. If you are able to solve these two parts, again, this will be covering quite a few parts. Theorem of parallel axis, displaced from midships, permeability, all those things would be taken care of by this particular question.
You go back to the answer of part A, please.
Okay, 1 second. Somebody is speaking. Let him complete. Beta, but tell me, you started off. Please repeat again. I didn't get you.
Could you please go back to the sheet with the answer?
That I'll go back to. Have you taken this one, part B at least?
Yes, sir. I've got it. Already got it.
Okay. I'm going back, guys, to part A. This is part A.
Got it, sir. Thank you.
Okay. So now what I'm trying to say is you will have permeability here in this part. So now you have no choice but to use theorem of parallel axis, guys. You can't escape that now. Otherwise, you will have 4 intact areas, A1, A2, partially here, partially here. That will be more cumbersome. So best will be whole minus lost if permeability is there. So this question is just to make sure that you don't lose sight of theorem of parallel axis. Okay, guys, now we can take a break and we come to the last topic as far as this particular GM component is concerned. It's 11:31. Okay, 12, 20 minutes. Okay, 11:40 we start. Take a 9 minutes break, guys. And in the meantime, if you have any doubt on what we have done, you can have a recap also and get back to me if there is a problem. 11:40 we continue, right, guys? Okay. I'll just unshare and Kiran says.
लेकिन actually में कभी होएगी नहीं ना, मतलब this is just we are imagining, no?
What?
Because यहाँ पे fuel oil और sea water replacement होगा, तो this condition in which the tank is empty will never happen actually, right?
What did I say, beta?
So
I
that we
use the word imaginary multiple times, I think, right? Hypothetical, imaginary, right?
okay. Then.
Okay, so when it is bilged, how can you empty it? It's bilged, correct? So now between these two conditions, what is called as the initial condition and the intermediate condition, everything is same except the condition of the dB. In one case, dB is empty. In other case, dB is full. Both these conditions, the ship is intact. Now let us say the ship gets both the dBs are bilged. Both the dBs are bilged. When both these dBs are bilged, what will happen to this particular case? This green part was already unchanged, but what will happen is this will basically be filled with seawater. Yes or no? Correct? Correct, guys? If the dB is bilged, this space will be occupied by seawater, correct? Guys, do you agree with
yes,
me?
Sir.
And,
Yes, sir.
Yes, sir. And in the other side, this fuel oil will be lost, and this will also be occupied by seawater now. Whether it happens immediately or after 10 days, that is not what I'm talking about. But do you agree that finally this entire fuel oil will be lost and this dB will also have the space occupied by seawater, correct? Correct, beta?
Yes, sir.
Yes, sir.
Yes, sir.
Now, don't you think these two ships have now become identical? The only difference was dB. Now the dB has also come in the same condition. The only difference between these two conditions was the condition of the dB. In one case, the dB was fuel oil full, other case, the dB was empty. Now, after bilging, both the dBs condition of both the ships going to be same, yes or no? After bilging, the ship in the intermediate condition would reach in the same stage as the ship in the initial condition, her dB getting bilged. Do you agree with me? If you do not, let me know, guys. Tell me. Yes or no? Guys, after bilging, would both the ships be in the identical condition? Yes or no?
Yes, sir. Yes, sir. Both will have their DB tank filled full of salt water.
And rest of the thing is same. In any case, same. The only difference was DB. Now the DB has also come to the same condition. Yes or no? Before bilging in both the ships, the only difference was the DB. One, the DB was full of fuel oil, other the DB was empty. After bilging, both the DBs have come to the same condition. That is, the space is occupied by seawater in both the cases. Yes or no? Correct, guys?
Yes, sir. But the densities would differ, no, sir?
Why? Seawater is seawater. Which density will differ?
No, we were taking the bunker, as in like we have the bunker of density 0.8, and then it is replaced by seawater of density 1.025.
So now in the ship where you had fuel oil, now what is the DB full of now after bilging? After bilging, what is it full of now?
Seawater.
And the intermediate condition where it is empty, what is that full of now after bilging?
Seawater, sir.
So both the ships have come to the same condition, no? Yes or no?
Okay, so we were talking about intermediate and the final. Okay.
These two conditions are identical. Yes or no?
Yes, sir. Completely.
Yes, sir.
After bilging, the initial condition of the ship, the vessel in the initial condition getting bilged, and the intermediate condition getting bilged. Post bilging, both ships come to the same condition. Yes or no? Identical condition. Correct?
Yes, sir.
Yes, sir. Agree.
So whatever will be the stability of the the intermediate vessel after bilging will be the stability of the other ship. Then their stabilities would be same. Yes or no?
Yes, sir.
Their stabilities would be same. Yes or no, beta? Tell me. After bilging.
Yes. Yes.
So that means what can I do? If my tank has a liquid, I first come to an imaginary condition, hypothetical condition, just an assumed condition, wherein I assume to pump out that liquid, and I call that as intermediate condition. Then I forget the initial condition, I bilge the intermediate condition, which is empty, which you already know how to bilge an empty compartment, right? And whatever will be the stability of that ship will be the stability of the vessel with liquid having got bilged. Yes or no?
Yes, sir.
Okay, don't worry. If there is any gap, let me see it through the question, and I'll again be discussing the same thing here and highlighting again. If anybody has any problem, I'll rediscuss the issue. No problem. A box-shaped vessel, 100-meter long, 20-meter wide. Our standard ship, 20-meter wide. kg 7.5. Is floating on even keel at a draft of 6 meters. Has a DB 2 meters high. Full of fuel oil, 0.95 RD. Calculate the GM of the vessel after the DB gets bilged. Okay. What are we going to do now? See, first let me calculate the displacement of the vessel in the initial condition. Displacement of the vessel in the initial condition will be length into breadth into draft into density. Can you please calculate and tell me what is that displacement coming to?
One two three zero zero.
12300 tons. Okay. The kg of the vessel in the initial condition is given in the question 7.5 meters. Okay. What will be the weight of the fuel oil in the dB? It will be the volume multiplied by density. So it will be 30 by 15, I think that is the size. Yeah. 30 meters by 20 meters into 2 meters is the volume into 0.95. How many tons is the weight of the fuel oil, beta?
1140.
1140. What will be the kg of the fuel oil, beta?
1 meter.
1 meter. Okay. Now, I basically come to an intermediate condition, okay, wherein the intermediate condition, I assume this oil to be pumped out. Ship is intact, not damaged yet. So what do? I have the displacement of the ship in the intermediate condition will become 12,300 minus 1140. How much does it come to, beta?
116.
1116, is it? ओके नहीं नहीं 20 आएगा एंड में तो यार 20 आएगा 11
11160.
1160 tons. Okay, I can find out the vessel's draft in the intermediate condition by law of flotation. 11160 divided by 1.025 divided by the length of the vessel and the breadth of the vessel. How many meters is the draft, guys?
5.444.
5.444. And I also find out the kg of the vessel in the intermediate condition. It will be initial vertical moment, which will be 12,300 into the kg of 7.5 minus the vertical moment of the oil assumed to have been discharged, that is 1140 into 1 divided by the final displacement 11160. How much is the kg, guys?
8.164.
8.164. Guys, any questions up to this point before I now continue further? Okay. So by using law of flotation, we have worked out an intermediate parameters, assuming the oil to have been pumped out. It's all assumption, okay? Now I am drawing the ship in the intermediate condition. My ship is like this, 100-meter long, 20-meter wide. Now floating at an even keel draft of 5.444. So I'm calling it as D here again, or D enter, whatever you want to call it, 5.444 meters. There is a midship compartment here with a dB of 2 meters height. And kg of this vessel, guys, incidentally now is 8.164. 8.164 meters. Please pay attention to the draft and kg. And this is now empty. Now, as I have explained, that between the blue diagram and the red diagram, everything is same. Only difference is in the blue diagram, the tank is full of fuel oil. In the red diagram, tank is empty. Otherwise, rest of the condition of the vessel is same. Do you agree with me? Yes or no? Guys, these two vessels drawn, one blue, one red. Do you agree that and everything is same as far as weights, their distribution is concerned, except the DB tank? In the initial condition, the DB is full of fuel oil. In the intermediate condition, DB is empty. Other than this difference, there is no other difference as far as weight and their distribution is concerned. Yes or no?
Yes, sir.
Agreed, guys? So if everything is same and only difference is DB, and if I now make the DB is also same, then the two ships have become same. Yes or no? Correct, beta? The only difference in DB, and if the DBs are brought to same condition, and both ships will become same. And this is exactly what the bilging would do. If you bilge both these compartments, the compartment which in the red one where it is empty, the space will be occupied by seawater. In blue one also, fuel oil will be lost and the dB space will be occupied by fresh seawater. So what has happened now? After bilging, the dB of both the ships will be in identical condition. Both will have seawater. Remaining ship was as it is same. So now the two ships have come to exactly identical condition after bilging, and therefore, whatever will be the stability of the red ship would be the bilged condition for the blue ship as well. Do you agree with it? Do you agree with it, guys?
Yes, sir.
Okay. So now I will ignore, not that I'll remove, I'll ignore the initial condition and my entire focus will be, so this part I will put out of my view now. I will not look at it at all. And I will only be, so let me go to the next page so that there is no confusion here. This is an MMD that you can do later on, no problem. Let me just add sheet here. Okay, now that means if I make this diagram, intermediate diagram here, intermediate condition, in which my length of the vessel is 100, my breadth is 20, my vessel is floating at an even keel draft of 5.444. Its kg is 8.162 meters, 164 meters. It has this dB as empty. And now I bilge this dB. What will happen? This buoyancy would be lost. This will cause the vessel to sink to a new waterline W1, L1. Now I can find out what is the sinkage. Sinkage would be the lost buoyancy, that is LBH, length is 30, breadth is 20, H is 2 LBH upon intact water plane. What is the water plane between WL and W1, L1? The water plane is fully intact, 100 by 20, right? So divide by 100 into 20 is 0.6 meters. This implies D1 will be equal to 5.444, which was the draft of the intermediate condition before bilging, plus the sinkage. It will be 6.044 meters. So this D1 will be equal to 6.044 meters. Do you all agree up to this point or any doubts, Beta? Guys, do you all agree?
Yes, sir.
Right? Now, KB will not be D1 by 2. We all know it. KB will not be D1 by 2. It will be by moments. So KB after bilging in the final condition will be vertical moment up to W1, L1. So that is length, breadth into D1 is 6.044 into liver is 6.044 by 2 minus the vertical moment of the underwater volume not contributing to buoyancy, that is the dB. 30 into 20 into 2 is the volume. Its liver will be 1 divided by volume of displacement. 100 into 2, 20 into draft. Be careful. The draft of the intermediate condition before bilging was 5.444. This will be the kg of the vessel, kb of the vessel after bilging. How much does it come to, guys? How much does it come to, beta?
So 3.245.
3.245.
245.
Is that correct, beta?
Yes, sir. 3.245.
Okay, fine. So that is the KB of the vessel after bilging. Now we find the BM. What is the water plane? It's fully intact. Center line will be the one passing through center of flotation. So BM will be equal to after bilging LB cube, so 100 into 20 cube by 12 divided by volume of displacement. Volume of displacement will be 100 into 20 into which draft, guys? Into which draft? Sorry.
Intermediate condition, sir.
So what is the draft?
Initial draft.
What is the initial value? Bolo, there will be confusion. I'm asking you the value. Now speak the value so that I know your 544. Because if you say initial, somebody may take it as 6 meters then.
No,
okay.
5.4.
Okay, so 20 square by 12D. How much is the BM, beta? 20 square by 12 into and 0.5444.
6.124.
124. So GM will be equal to the KB 3.245 plus BM 6.124 minus kg. Now in the intermediate condition, the kg is 8.164, guys. 8.164 before bilging. And this should give you the GM of 1.204 meters as the answer. If it is not giving, then there is something somewhere we have missed out. 1 decimal place here and there is fine, but if there is a huge difference, then we can look at it. This is how you will handle bilging compartment which carries liquid. How will you deal with it? You'll first work out an intermediate condition. What is that intermediate condition? A, it's an imaginary condition. It is not actual. What are you imagining or assuming? In which you're assuming that the concerned compartment, the liquid is pumped out and emptied. And if you do so, it will change the ship's draft, it will change the ship's kg, and it will empty the tank. Now you with the, yeah, tell me beta.
तो जैसे हमने मीन अपने ड्राफ्ट निकाला है वहां पे सर मीन राइज भी एज लाइक सिंकेज निकाल देते तो निकाल के भी हम लोग नया ड्राफ्ट निकाल सकते हैं।
वो तुम्हारी मर्जी जैसे निकालना है बेटा, ठीक है। ये बहुत ज्यादा डिफिकल्ट हो गया निकालना। दिस वेरी डिफिकल्ट इज इट?
नहीं।
तो फिर फर्स्ट प्रिंसिपल में क्या प्रॉब्लम है? फिर सिंकेज को ऐड करते घूमोगे, सब्ट्रैक्ट करते घूमोगे राइज को, मतलब अननेसेसरी कंफ्यूजन क्यों करना लाइफ में? सिंकेज नहीं होगा, राइज होगा बेटे। देखो वैसे तूने गलत बोल दिया, फिर ऐड करोगे तो प्रॉब्लम हो जाएगा ना 6 में। So anyway, you can do that. Why not? You can always do that. That will be 1140 divided by 100 by and also 20. So that will give you the rise, but you'll have to then subtract unnecessarily. Why go in circles? Your choice.
Okay.
So guys, whenever there is a liquid in the tank, from initial condition, let me change to green marker and I write this here, that from green marker, from the initial condition, you will work out an imaginary condition called as the intermediate one. This word has been not a standard word and people can use differently also, no problem. And then you will come to final, bilge the intermediate. You will bilge the intermediate and get the stability. This is the step to be followed if the compartment carries liquid before bilging. Is that clear, beta?
Yes.
Review this. If there is any doubt, anything which you think is contradicting with logic, we can always take it up tomorrow again. There's absolutely no problem. And then there is one last question from MMD. I think so. Yeah, it was from one of the MMD papers. What is the difference in this question? Just see. What is the difference? I have intentionally included here because it is from MMD, so you should not get confused. How does this question differ from others? Guys, what is the problem with this question?
Initial GM is given, so we
So
have to calculate.
Yes. So
BG.
you will have to in the intact condition, you'll have to calculate KB, BM, get the KM in the intact condition. Then you will subtract GM, and that will give you the kg to be used. Is that clear, beta? Understood?
Yes.
So you'll have to get the kg and then proceed. That's the additional work which is there for you. So this question is for you to solve. I am sending these questions to you. Please solve them. With this, we come to end of this entire thing. Okay. Guys, that question of 65% permeability of central line, the forward compartment is not in this, but I hope you have taken the screenshot, right? You've taken the screenshot, correct, beta? Anyway, you can take this question also. Now, I'll send you this, but if something is missed out, don't just leave it out. So with this, we come to end of one part of bilging, that is effect of bilging on GM. Effect of, so I don't like to call it as midship compartment. I would call it effect of bilging on GM of the vessel. That means calculating the GM of the ship after bilging, wherever the compartment may be. So this topic is complete end to end. If you got the things right yesterday, then I don't think today should be too much difficult. It's only adding few specific instances and cases. And guys, tell me बेटा.
क्वेश्चन वाला पेज ला देंगे सर, स्क्रीनशॉट ले लेंगे.
मैं भेज देता हूँ, तो उसको मत लो, मैं भेज देता हूँ. I'll just say.